12-1 tangents to circle. Please excuse my voice because I have really bad allergies. I'm sorry about that. Properties of tangents. The point at which a tangent line intersects the circle to which it is tangent is called the point of tangency. What it looks like. If you have a line that touches the circle that way, that is called point of tangency right here. Theorems. If a line is a tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. This is very important to know. So right here, this is your tangent line. This is the point of tangency, and from radius to that is always perpendicular 90 degrees angle. Converse, also true. In a plane, if a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent to the circle. So, which means that in a plane, if this line right touching the circle, and the radius is right here, and then if they are perpendicular, if they make 90-degree angle, this line is tangent to this circle. So we're just going backwards, which is also true. That will be the converse for that. So we're going to find the radius of a circle using this information. On your picture, you have this triangle. This triangle is a right triangle. This R means radius. This R means radius. I'm giving you the 8 right here. That's given information. I'm giving you that 16. So this tangent line is 16 in length. And please look at this perpendicular 90-degree angle. So with these information, triangle ABC, we're going to find R. We're going to use Pythagorean theorem because this is a right triangle. Tangent line, the point of tangency is always perpendicular to the radius, so tangent line is 90. So what we're going to do is across from 90, this A and C, this line is your hypotenuse. Hypotenuse always across from 90-degree angle. So this is going to be your hypotenuse, this is going to be your leg, and you're going to do, this is another leg. So we're going to write A squared plus B squared equals C squared. So A is 16 squared plus R squared equals C squared. As you can see, the C right here is 8 plus R or R plus 8. Doesn't matter. And then we're going to solve for R. 16 squared is 256. R squared is R squared. We're going to multiply these two. So R plus 8 plus R squared is 8 plus R times 8 plus R, which is R squared plus 16R plus 64. So if you do this multiplication, this is what you get. Now, we can cross cancel R squared and R squared, because if I subtract over, it's going to cancel out. Now you have 256 equals 16R plus 64. This is the same thing, so we canceled out. Then we're going to solve for R. Subtract 64 from 256, you get 192. Divide each side by 16, I get 12. So this R is 12. Now, if you're confused with how to do A plus R squared, I did a little bit of here. A plus R times A plus R, you use FOIL. 8 times 8 is 64. 8 times R is 8R. 8 times R times 8 is 8R. R times R is R squared. So this right here in the middle is 16R. So that's how you do this in case you forgot how to FOIL or box method. FOIL means front, outer, inner, last. So that's how I go from here to here. So please copy this. This is 16R in the middle. So once you do that, you can actually solve for R. This is 12. That's 12. That means this length is 20. So 12, 20, 16. So if you do 12 square plus 16 square, it should equal 20 square. So checking if a line is tangent. Let's take a look at this diagram. This is radius. That is a tangent. This is 13 here. So what we're going to do is use Pythagorean theorem to see if this line is tangent to this circle. So what we're going to do is write 5 square plus 12 square should equal 18 square. Where did I get 18? If this is 13, this radius is 5. So from MP is 18. So you have to use, this 13 is from only here to the circle. So the rest is 5. So that's what you have to use, 18. So we're going to do 5 square plus 144 equals 324. I do 5 square, 12 square, 18 square. And then 25 plus 144 is 169. 324, they're not equal to each other. And this is not a right triangle. So this is not a tangent. This line, MN, this line 12, is not tangent to this circle. So that's not tangent. So you have to prove using Pythagorean theorem. These two, when you add, has to equal to c squared. How do you know if this is c squared? Across from 90 is c squared. So this is your hypotenuse. Hypotenuse always across from 90. So this one is not equal to each other, so that one is not 90. Theorem. If two segments from the same exterior point are both tangent to a circle, then they are congruent. So right here, if two segments from the same exterior, right here, are both tangents to a circle, they are congruent. So here you have a radius. This line is tangent to this radius, to this circle, because it actually makes 90 degrees. This line is also 90 away from this point of tangency is 90 away from the same radius. That means AB, tangent line, is congruent to BC. That's why I did the congruent marks. So basically, this line is congruent because they're both exterior and they're both tangent to a circle because they make perpendicular to the radius. Let's look at this example. I'm sorry about my voice. Circle S is inscribed, means inside, triangle LMN. This is the triangle. What is the perimeter of triangle LMN? First of all, these two lines right here, they are congruent because this is a tangent line to this circle. If I draw that, that is perpendicular. So if this is 8, L to R here, if that's 8, this one, L to O, right, this line is also tangent line. That is perpendicular to S circle. That's 8. So can you do this mark, congruent marks? And then this is 8 and 8. Okay? And then the next one, this is up to 8 here. From here to here is 5. That's a tangent line to this circle. So then this is also tangent line to that circle. They're both 90 perpendicular. So if this is 5, then this is 5. So please do 2 marks, congruent marks, 5 and 5. And then from here to here, if this is 14, this is perpendicular, that's a tangent line, then this is 14. Okay? So these two, do 3 marks, 3 lines, congruent marks. So that's 14. Then we're going to add 8 plus 8, 16, plus 14, 14, 28, plus 5, 5, 10. Then you got all the perimeter outside of this triangle, which is 54. So that's how you get the perimeter. So now I want you to do the worksheet that is attached to the lesson by using the notes. I want you to skip some questions because it's too much. So I want you to listen here and please circle. I want you to do number 1. And then I want you to skip this question. You don't need to do this question. Okay. And then I want you to skip number 2. So don't do number 2. No. And I want you to do number 3. These 3. Okay. And then I want you to skip number 4. I want you to do 5. All 4 and 5. I want you to do 6. That one is easy. Skip 7. And then do number 8. Okay. Do number 8. But you can skip this last one. Don't do this one. Okay. So please just do those. And then I'm going to basically you're skipping number 2 and then skipping number 4 and skipping number 7, and then you're skipping this one question from number 1, but you're doing these 2. Okay. And then you are skipping this question from number 8, but you're doing these 4. This. Okay. And then I'm going to put the answer key on Google Classroom tomorrow, so you can actually check it, okay, when you come to class. And then you can do this, whenever you can. So tomorrow I'll put the answer key so you can self-check, okay? All right, thank you.